Hello everyone, I am Dr. Chinmay Kumar Sahu. I am going to discuss about electric discharge machining in the non-conventional machining series. It is famously known as EDM. It stands for electric discharge machining. In this electric discharge machining, it is used for machining or removal of the material from the hard and conductive material. It cannot be used for the non-conductive material. But prior to that, we should know that the electric arc or spark here electric spark is used because electric spark contain a high amount of energy. Earlier, we already visualize this type of scenario when the lighting cause a lot of accident, firing, even the burning of the tree, etc. And electric energy also can be used for the welding purpose, and it can be effectively used for joining two different hard materials. For prior to that, we should know the schematic diagram of the the schematic diagram of the EDM. This is a simple schematic diagram of EDM machine setup. In this thing, two things is that one is the tool, another is the workpiece. Okay. Both should be in the conductive in nature. When the tool and the workpiece is connected to the DC supply, here we should remember that here we are using a pulse generator, which supply the electricity in a pulse manner. One cycle it will supply, another cycle it will stop. So what happens when it is connected to tool is connected to cathode, that is a negative polarity, and the workpiece is connected to the positive polarity. When the electron moves through the tool and tries to jump through the workpiece, but there is a certain gap between the tool and workpiece, and this gap is filled with a liquid known as the dielectric. Different type of dielectric can be used, just like the distilled water, transformer oil, kerosene, etc. These are non-conductor of electricity. When sufficient potential difference gap is maintained and potential difference is applied, so what will happen? The electron will try to jump from the tool to the workpiece. Electron simply first collide with the dielectric material which is surrounded the gap. So electron strike to the atom of the dielectric material and it will create a plasma state or the plasma channel, which is a conductor of electricity. Small channel, narrow channel. At that time, a high amount of electric energy, electron will be jumped from the tool, means cathode, to the anode. When this sudden electric discharge appears as a spark, this spark contains a high amount of energy. When it strikes to the workpiece, it will rise the local temperature of the striking point to a high temperature. Temperature reaches the workpiece, local temperature reaches the workpiece up to 10,000 degrees centigrade. At that high temperature, metal simply vaporize and melt. Okay. At that time, when it will be melted and vaporizes, the dielectric surrounded the gap will simply take away the waste product. And we should remember that this dielectric need to be continuously recirculated and cleaned. This is the basic principle of the EDM process. This is the one of the another process where the dielectric is supplied through the tool material. This is the tool 9. This is the workpiece material, the 2. Okay. Better what is the tool material property? We should know it. Tool material should be conductive in nature, and tool material should be loss of the tool material should be less compared to the workpiece. Different type of tool material we are using. Famous is the copper, then graphite and brass. And and another thing is that which is the important one, dielectric material property. First thing is that it should be non-conductive in nature. What I have told you earlier. It should helps in the spark, and it also carries the residue material from the machining area. And second, the third and most important part is that it maintains the machining temperature. If temperature is high, it can damage to the workpiece or it can damage to the machining process. Various examples of the distilled water is of dielectric distilled water, kerosene, paraffin, vegetable oil. The idiom has certain advantages, so we are going to use it. First one is that tool and workpiece are not contact with each other. That means no physical force is applied to the workpiece. Machine is independent of workpiece hardness. As I have told you earlier, no physical contact between the tool and workpiece. But it has certain limitations, like only conductive. Remember that only conductive material can be machined. And material removal rate is very low compared to the conventional machining process like milling, turning, etc. And machine cost is high. That creates a high machining cost. It has certain application like it is famously used for the die sinking, that is manufacturing of dies, making blind hole, removal of the broken drill bit, machine thin and fragile component just like the silicon, germanium, etc. and many more. Thank you for watching this, and please you can follow the different book. One is the one famous is the PC Misra. Second one you also can follow any other book also, but if you want to learn detail about it, you can follow the VK channel. Thank you.